Hello everyone. So in this video, we are going to see how to carry out the extension of range of an ammeter. I have provided you an assignment where you have to do the extension of range of an ammeter as well as extension of range of a voltmeter. So I had already shared the circuit diagram with you. So this circuit diagram was already shared beforehand, and you can see in this example, the main circuit is having a current. So you can see I placed a DC source and a main resistor, and I have placed an ammeter to make the measurement. So this particular ammeter is able to measure only 1 ampere current, and we need to extend the range of this ammeter such that it is able to measure 11 amperes of current. So the verification is actually done through the simulation over here. So a resistor is placed in series with this particular ammeter because the ammeters present in MATLAB are ideal. So I just double clicked it and you can see they don't have an inbuilt resistance. So this particular resistor over here, it is showing the internal resistance of the ammeter. And you can see we have connected a resistor in parallel, that is the shunt resistance, which is allowing you to measure 11 current using the same ammeter. I have placed this ammeter to show that 11 ampere current is actually flowing through the circuit, and this ammeter, through this particular ammeter, you're able to see only 1 ampere current. So we can see how you can do this particular simulation in MATLAB. So you can see over here that if you have already installed MATLAB, you can search for MATLAB. I have installed the version of 2022B. If it is always better to download the latest versions. So you can download the 2025B using the MATLAB license that we are already having. You already have the institutional license and you can install the latest version of MATLAB. On clicking the MATLAB over here, you will come to such a window. And in this particular command window, you can do the coding part. We are going to do the simulation of an electrical circuit. So you can click on Simulink. So once you click on Simulink, you're going to come onto such a page like this, and you can click on blank model. So once you click on blank model, it's going to take some time to load the new blank model. So you can just click on blank model and it will take you to this page. A simple untitled page which is having a blank canvas. Okay, so this is the area where you're going to do the simulation part. Right. So in order to provide the components, so you can, as we had already seen in the previous circuit, you are having resistors, you're having current measurement circuits, you're having DC voltage source. So in order to take all these elements, you can just double click. So this is your untitled page. You can double click over here and you can search for resistor. So I've simply double clicked and I'm searching for resistor. So I have the first option that is going to give me a resistor. So I just zoom on over here. And you can see the color of the resistor is blue in color. So you can see that in the original circuit, I need 1, 2, 3 resistors. And so what I'm going to do over here is that I'm going to right click on this resistor and just drag it. So I got another resistor, again drag it. Or you can just copy it and paste it. That's also fine. Now you can see I need to just rotate this resistor. You can see it's rotated. This particular resistor is rotated. So you can just on the keyboard, you can just select on your resistor and then give Control R and that will rotate your resistor. So the next thing that I need are current sensors. So I'm going to double click. I'm going to search for current sensor. And as you can see in this circuit, I need 2 current sensors. So I'm going to take 2 current sensors, right? So I hope it's fine. It off like this. So I'm going to make the connection up to which I have right now. And I'm completing the connection. Right. So it's not complete because I need a DC voltage source. So I'm double clicking and I'm searching for DC voltage source. So you can see there are 2 options. You can take both the options and I'll tell you the difference between them. So this is one option. That was the first option. If you take the second option, now you just look at it over here. You can see that this DC voltage source is blue in color, whereas this one is black in color. So all the components that we have taken over here are actually blue in color. So you can discard the black one and you can use the blue one. Right. So I'm completing my circuit. Right. So my circuit is complete, and if I try to run this, what's going to happen is that it's going to show some error because you haven't provided a solver configuration and a reference. So I need to provide an electrical reference in order to avoid the errors. So I'm going to take an electrical reference. The first option is good. And you're going to need a solver configuration. If you run it like this, again, it's going to show an error. So you need a solver configuration, and you can connect it over here. Right. So now if you run it, you're not going to get any errors, but then again, you can see over here, you're not able to see any values of the circuit. Right. For example, in the example that I had shown, you could see 11 amperes and 1 ampere. So you need a display circuit for that. So you can just take display. So the display component, I'm taking two display components. Now, if you try to connect the display component directly to the ammeter, it's not going to allow you to connect it. The reason is you can see that this display block that you have, it's actually black in color, and all the other components that you have are actually blue in color. We can just see that over here. All these are blue in color, and your display is actually black in color. So in order to connect the blue and the black components, you can search for a PS to Simulink converter. You just type PS, and the first option you'll get is the PS to Simulink converter. So I'm going to give that here. I need two of them because I have two current sources, sorry, current sensors. So I guess, right, this is good enough. And if you run the circuit, you're going to get the answer. Now you can see over here, you're getting some random values. The reason is that inbuilt, you can see they are having some voltage values. If you double click this, you'll see some resistance values of 1. So after designing your circuit, you have to find out the value of RS and RM. Sorry, RSH and RM. You have to provide the values, provide the value of the DC source and the resistance. Okay. So you have to complete this, and I'll just show you the values that I have given. My DC source value is 110. The value of my RSH is 0.001. I have changed the values. The value of my RM is 0.001. Here it was two zeros, here it was three zeros, and my resistance over here was 10 ampere, sorry, 10 ohm. And when I run the circuit, I have got the exact ratio of 11 is to 1, that is 11 by 1 is 11. So I hope you'll be able to do this assignment. If you have any doubts, you can always contact me. So you have to complete two circuits. One is the extension of the range of the ammeter and the extension of range of voltmeter. So you can use the same concept. There's only going to be a small difference. You have to use the voltage sensor instead of a current sensor over here. All the remaining components are going to be the same. Okay, so if you have any doubts, you can always contact me. Thank you.